Hello, good morning, all the student. Okay, anybody is on the line now? Hello, morning, Iru. Okay, good morning. Okay, today I want to go through our last lesson for the online lesson. So after that, we holiday. Okay, after 1 week, we go back to school. So we're still teaching by using the board lah, whiteboard. Okay, so from here, today I want to discuss about the formative practice, the 2.3, about all the gas pressure exercise. Okay, morning, Jessica. Yes, Sabrina, morning. Okay, so today we continue for the exercise. Hopefully you are finished all the exercise. Then now you go check your answer. Okay, so we go through to the question. So you prepare your calculator. Then you also can be shown in the chat room there. Okay, so from here we go through the question. Okay, first one should be the formative practice 2.3 from your textbook. So today we want to discuss about the answer. Okay, let's see there. Okay, forget to ask. You can listen me or not. Okay, because nobody go to respond me. Okay, can listen me or not? Okay, we got three in the chat room. Can answer me. You can listen me. Okay, we got Jessica, Sabrina, and Yiru. Can okay, thank you thank you Ling Han Okay, so I want to continue the formative lah. Okay, let's see here. Okay, the first question. Okay, they show about the water manometer. They connected to the, okay, morning to you, Xuan. Okay, Esther. Okay, we go to formative practice today. Want to give you the answer. Okay, you see they connected to the flask. After that, the containing of the glass. Now the compare the glass pressure. Oh, sorry, gas pressure. Okay, we got two level, is it? This one is a gas. Another one they just open for the atmospheric pressure. So you need to compare the gas pressure and atmospheric. When you see the diagram, then you understood which one pressure should be higher, gas or atmospheric. Okay, you can see the level. Which one stronger? That means they can push, become strong. So another side should be up, like, is it? So from here, which one becomes stronger? Okay, please answer me. Okay, we just see the question. I think the question is okay, not so harder. Okay, just a simple question only. Okay, which one becomes stronger? Okay, we just compare lah. Okay, they ask you compare. So we just say the level lah. Okay, Yiru, give me the answer is the gas pressure is higher than the atmospheric pressure. Yes. Okay, so you need to answer full sentence. Don't say higher. Then we don't know what is that. So you must have the in front, behind the subject is what. So from here we get the answer. Gas pressure. Okay, so from here we find it the gas pressure is stronger. So that's why they can push the water up, okay, to another side. So another side is what pressure? Atmospheric pressure. So from here, I show you the answer. The gas pressure is higher than atmospheric pressure. Okay, so correct the answer from Yiru. Okay, now we go to second one. State the difference between the gas pressure and atmospheric. Okay, in the meter H2O. So this one is a water, so they want to count by H2O, then they will count for mercury. Okay, just now you say gas pressure is higher, is it? Now I need to know the higher how many? What's the difference? Okay, we need to know the difference, but you just refer the diagram, then you know the difference already. They already show you what's the answer, is it? But you need to write in the unit they provided. Okay, the unit they want meter H2O. Okay, what is your answer? Okay, 0.36. Okay, we just copy here because this one is cm, is it? You help me to convert become meter. So from here I just show the answer. Okay, we just got Yiru to answer me only. The other where to go already? Sabrina, where to go already? Okay, so from here I just show. Okay, the different, okay, you find it, the answer CmH2O is it? But the final answer, they want in meter. So you need to write your answer in meter. Okay, so from here, the answer should be 0.36 meter, after that H2O. Okay, that one is a unit when they're using the liquid is a water. Okay, I think this one is no problem. Okay, Ling Han, I see your answer already correct. Okay, then we go to the next part. Okay, next part is a calculation already. Okay, they say about this one gas pressure, I want in Pascal. Just now you say in meter, H2O. Now I want in Pascal. Okay, after that, they say density of the water provided, 1000. Okay, this one is for water density. Gravitational 9.81. Then don't forget atmospheric pressure. Okay, now the gas pressure is here, same level, same pressure. So we need to find this part. So this part we got what pressure? We got water pressure 36 cm mercury, cm H2O, and also atmospheric pressure. So first part, we go to plus by unit meter H2O first. Okay, after you plus become meter H2O, then after that you go to chain become Pascal. Okay, they're more simple lah. You no need to change Pascal so long. After that, you plus together. Then you also can do like that. Depends for yours. Okay, so from here, I show the first part. Okay, this one is an info. Atmospheric 10.3 meter H2O, then 9.81. Then this one density for the water. Gas pressure is how many? Okay, Jia, so fast already. 104574. 0.6 Pascal. Okay, so now we go to check. Is it Jaya correct or not? Okay, then the Hayward. Hayward also show me. Okay, Brandley Hayward. They show me the answer also same. Sabrina also correct. Okay, now we go to check. Is it correct or not? Okay, now we go to show. Okay, gas pressure equal H rho G. H rho G for water plus atmospheric pressure. So from here, I need to convert lah. Okay, 10.3 meter H2O. This one is the atmospheric. Plus just now, you give me the answer, 0.36 meter H2O. So suppose it's a 10.66 meter H2O. Okay, from here, I need to convert become Pascal. So when I convert become Pascal, this one is all H2O. That means the density must using the water density. Okay, let's see here. I using the formula 10.66. This one is a H. Then the rho 1000. Then this one is a G. Okay, final answer. Okay, is it correct? Yeah, exactly correct. Okay, 104. 57. Oh, I go to round number because 0.6 is it. So that's why I make in front. So become 5 Pascal. Okay, you also can put 0.6. It's okay one. Okay, so the answer is okay lah, correct. Okay, then we go to the next question, question number 2. Okay, question number 2, they ask what is the advantages with using the mercury manometer compared to the water. Okay, important is density. Density of the mercury should be higher. If the density higher, that means I can measure the pressure is higher some more. Okay, because your water excuse me, water density is a low. Okay, low, very low. So that means I just can measure certain of the pressure only. Okay, if you want to using the higher pressure you want to measure, that means the tube must be very, very long. Okay, because of the height. Okay, now we go through the what's the answer? Okay, the first one they say mercury able to measure the higher pressure because mercury is a denser liquid. Okay, first one you must talking about the density lah. Okay, compare about density mercury and also the water. Okay, mercury is a bigger, so you can refer the formula H rho G. G already is constant, so we don't see about the G. Okay, important is a rho. If the rho become higher, that means the H you become shorter. Okay, the H become shorter. So that means you're using the tube, manometer tube become shorter. If you're using water, okay, remember just now we show the water atmospheric is how many? 10.2 meter H2O. That means when you do the experiment, the manometer already is 10.2, but just atmospheric. So that means water actually is not suitable to measure the high pressure. Okay, then we go through to the second point. Not just one point only. We go to second point. Second point is does not need a very long tube. Okay, just now we explained high density. Okay, for the water, sorry, for the mercury, then the water is a low density, so that's why they need very high tube. Okay, then after that, the last one is evaporation. Rate of evaporation mercury is lower than the rate evaporation of the water. So that means if you're using the water that easy to evaporate, so that means the manometer, the tube inside, there will be less. Okay, mercury that take longer time. So that means they can use for longer time for the mercury. Okay, this one is a three advantages why we choose mercury as a manometer. We never choose about the water manometer. Okay, then we go through to the next part. Okay, the next part is a mercury manometer. It connected to the steel cylinder containing the compressed gas. Okay, so that means the manometer, you just imagine now we got two column, is it? One end they open for the atmospheric, another one they join with the gas. Okay, now the pressure of the compressed gas and the atmospheric pressure are, okay, they give you the pressure for the two part. Okay, atmospheric is a 101 kilopascal. Okay, for the gas, 180 kilopascal. So that means the gas pressure is higher. Okay, so you can imagine if the gas pressure is higher, that means they can push until the atmospheric pressure, the part will be higher. Okay, now we need to calculate the difference in height. Okay, we do want to calculate different on pressure. Different on pressure we know already. We minus, then we know already. But the question, they want to know the height between the two mercury coulomb in the manometer. Okay, so from here we need to show the info first. Okay, this one is the info. Atmospheric is 101, but the gas pressure is 180. So understood, the gas pressure will push. Okay, this one is a mercury. They push the mercury. After that, another side, the mercury will be up. Okay, now the question they ask, up how many? Okay, the gas pressure push the mercury pressure. Sorry, the atmospheric pressure. They up how many? Okay, they want to know the meter. So from here, you want to know the meter. We need to find out what is the different pressure first. Okay, so anybody here can tell me what is the different pressure? Okay, between the atmospheric and also the gas pressure. Okay, you give me the answer in kilopascal first. Okay, the difference. Okay, this one question is no diagram. So you want to imagine. If not, you can draw by yourself. Okay, just draw the manometer, one joined by gas tube, another one is open. So then you push. Okay, push the gas pressure, then the another side, the liquid up. Okay, the difference is 79 kilopascal. Okay, Sabrina and also Yiru, they show me 79 kilopascal. So from here, how to calculate? We just minus like Z. So Eric Chu also here, 79 kilopascal. Okay, so from here, we show the difference first. 180 minus 101. Okay, so from here we get the answer 79 kilopascal. But this one not the answer. This one just different pressure. I want to know it's a different height. Okay, so you want to find the different height, so I need to show like this. P equal H rho G, same formula, but now I know the P. P is a different pressure. So the different pressure now like this, 79 times 10 power of 3, because this one is a kilo. Okay, then the H I do know. Different, the H is a different height. Then the density, now we're using mercury. There should be density for mercury, then 9.81. Okay, final answer. Can you tell me what's the different height? Okay, I just want to know the different height. Okay, just now we just want to guide how to get the different pressure. So that's why we can find the different height. Okay, so now, so I just wait your answer lah for the H. Okay, Sabrina already give me 0.592 meter. Okay, normally we answer in meter lah because this one already changed it become standard form, is it? If want to give me the cm, still okay because the question never say they want SI unit. Okay, so I go to show. Okay, 0.592 meter. Okay, so some student they want to give me the cm, still okay lah, 59.2 cm. Okay, so this one is the answer. How to find another way? Okay, the question give you the pressure, then you need to find the height. Okay, so understand the question, then make sure what they ask. Don't simply straightforward go to do. Yes, Eric, that's a correct. Huh? Okay, then we go through to the okay, another paper I give you. That one is about the solving problem in the daily life involving for the gas pressure. I show you the diagram first. Sorry, this one is no diagram. This one straightforward. First question. Okay, let's see the first question. The gas pressure in the cylinder. Okay, they show about the cylinder. There's a 1,500 millibar. Okay, now the gas pressure is they calculate by millibar. Okay, between a water manometer and mercury manometer, which one is most suitable to measure the pressure of the gas in the cylinder? Okay, first one we need to know atmospheric pressure is how many bar first. Okay, I show you the first sentence. Atmospheric pressure is 1,013 millibar. Okay, and also if I say one atmospheric pressure, there's a how many meter in H2O? There's a 10.2 meter. Okay, but you can see this one situation. The gas pressure is how many? 1,500. 1,500 means the more than atmospheric. Agree or not? Okay, the more than atmospheric, you see, my if I using water, I need to using the tube is 10.2 meter. Now you are more than atmospheric. So what you think about the tube? The tube must be increased lah. Agree or not? Okay. Excuse me. Okay, increase how many? 1,000 already using 10.2. Now you add 500 more. So that means I need add 5 cm lah. 5 meter, sorry, 5 meter. So I need to using 15.2 meter H2O. So you think, is it water manometer suitable or not? Then sure it's not suitable, lah, is it? Okay, so from here, if not suitable, we need to explain. Okay, how to explain? First one, you show this one. The atmospheric pressure is how many first? Okay, number two, you must say the differences. Difference in the pressure is around 487 millibar. So that means the gas pressure now becomes stronger. Okay, they're higher than the atmospheric, around 487 millibar. So from here, we need to explain again. Gas pressure in the cylinder, they already exceed the atmospheric pressure, around 487 millibar. So the mercury manometer is more suitable as measuring the instrument for the gas pressure. So you can add some more. If you're using the water manometer, so that means the tube must be longer. Around how many? 15 meter. So that means the water manometer is not suitable. Okay. So important, the keyword you need to say about the different in pressure. You show the different in pressure is how many? Number three, you must say the over. They already over atmospheric pressure so much. So finally, you say mercury more suitable. Excuse me. Okay, so this one is a question number one. No calculation, just explanation why we need to choose the mercury manometer. Okay, then we go through to the second one. Okay, second one, you can refer the diagram. This one got diagram. Okay, I think this one paper I already upload for last lesson. If not, you can go to description there. I already is put the link there. Then you can go there and download. Okay, now the figure they show about the mercury manometer connected to the container that contain the A. Okay, here is a A. This one should be the mercury. Okay, again, state the whether the A pressure in the container is higher or lower than atmospheric pressure. Then we need to explain. Okay, which one higher? They ask about the A pressure. So what's your answer? A pressure become higher, or you say atmospheric pressure become higher? Okay, you see the level, then you understood which one becomes stronger. Stronger one, sure they can push more, is it? So from here you find it. Okay, the stronger should be. Okay, anybody here can answer? Okay, which one is a higher pressure? Okay, air pressure higher or lower than atmospheric? Then we need to explain why you know like that. Okay, when you explain, you say about the column lah, the mercury in the two column. Which one level is higher? Then this one is your explanation. So from here, okay, anybody can answer me which one pressure? Okay, they say A pressure container higher and low or lower. So you just answer me lah, lower or higher. That's all because the question already is there. Okay, anybody? Air pressure in the container is what? Okay. So anybody here? Okay, lower. Okay, air pressure is lower than the atmospheric. Okay, so the answer should be the lower lah. Okay, atmospheric, the air pressure in container is lower than the atmospheric pressure. Okay, so from here, you need to explain, not simply say lower only. So the explanation, we're talking about the level lah. So important is the left arm. The left arm mercury already push up by the atmospheric pressure. Push up how many? 24 cm. So that's why we know atmospheric pressure is stronger. So from here, the explanation is, okay, Sharon, okay, lower, that's correct. Okay, Yuan Ru is here already. Okay, because the atmospheric pressure can push the mercury up. Okay, you say air pressure lower, is it? Means atmospheric pressure is higher lah. So now atmospheric pressure that can push the mercury up to another arm. Okay, another arm is joined with the air pressure. So up how many? 24 cm. So we understood atmospheric pressure now is stronger. Okay, so this one is how to explain. We're just talking about the level lah. Okay, which one stronger? That means they can push the mercury to up another arm. Okay, after that you mentioned that up how many? 24 cm. Okay, so from here, this one is the first explanation about the level. Okay, second one, calculation. Calculate the different pressure between the atmospheric pressure in the container, air pressure in the container, and also atmospheric pressure. So that means you want to calculate the different pressure. Okay, so from here, they already give you the info, density, and also gravitational acceleration. Means your answer must in Pascal. Okay, must in Pascal. Okay, so from here, we go through the info first. Okay, the height is 0.24. Okay, change cm convert become meter. Okay, then the G already 9.81. Okay, this one is a mercury. So that's why they give you density of mercury. Okay, now they ask what is the different pressure. So can you count for me? What is the different pressure? Okay, I just want the answer for different pressure. From this one question, they never provide the atmospheric. Okay, because they just want to find the difference. We know the difference of the height, then we can do the calculation. Okay, so Sabrina, give me the answer already. 32,019.84 Pascal. Okay, we go to check. Is it the answer correct or not? Okay, got others or not? Okay, if two or three, the answer almost the same should be the correct lah. Okay, yeah, Ling Han and Yiru also is the same answer. Okay, so we just go to show different pressure. We're using H0G. So the H0.24, this one is a density, and this one is a G, 9.81. So final answer, yeah, 32020. Okay, maybe you add 4, then I go to round number. I don't want to go decimal point. So I put 32020 Pascal. It's okay. If put decimal point, also can. Okay, because too long already, we cannot do write so many things. If you want to change become standard form, also can. Standard form at least got 2 decimal point behind lah. 3.20 times 10 power of 4. Okay, that one also correct. Okay, so this one is just simple. We find the different pressure. Okay, we continue with the another question, question 3. Okay, now water manometer. Okay, now is water, water manometer. Very important when you read the question. We need to know there's mercury or water. Okay, connected to the oxygen cylinder. Now the reading of the aneroid barometer nearby 756 millimeter mercury. Okay, actually, what's the meaning for this sentence? Aneroid barometer nearby 756 millimeter mercury. Actually, what's the meaning? Okay, this one actually they want to tell you what information. Okay, analog barometer. Analog barometer actually they want to measure what? Okay, nearby. They want to show you the nearby. Okay, anybody can tell me? Analog barometer nearby actually is represent what? Okay, so I just want to know is it you understand the question or not? Okay, analog barometer we learned before, this one barometer. Okay, they said this one analog barometer they put nearby. Then they get it the reading like this 756 millimeter mercury. Actually, this one is what? Okay, analog barometer. Yeah, correct, Ling Han. Okay, analog barometer nearby means they want to measure atmospheric pressure is how many. Okay, that is a atmospheric pressure. So that means the question never straightforward to tell you atmospheric pressure how many, yeah? So you need to understood. So from here we know the atmospheric pressure is a 756 millimeter. So later you go to convert. Okay, A, they want you calculate the oxygen pressure in the Pascal. Okay, oxygen pressure, same level, same pressure. So we need to find this level. So we got 38 cm is water pressure and also atmospheric pressure. Okay, show info first. So this one is a info. Atmospheric is a 756. Okay, if you want to convert, you have to change become meter. Okay, the different height is 0.38. Density, sorry, this one is a gravitational. Okay, density they give you two. One is for the mercury, another one for the water. Now they ask about oxygen pressure is how many. So from here we need to show the equation first. Okay, oxygen pressure actually is a water pressure and also atmospheric. Agree, yeah? Okay, now I need to separate to calculate because density is a difference. We cannot say, oh, we plus together 38 plus about the 0.75. No, cannot do like this. If you convert to meter, becomes 7.56. Sorry, 0.756. We cannot say 38, I convert become meter 0.38 plus 0.75. Then after that, we multiply density, then gravitational. No, cannot do like that because now you are two different liquid. One is for water, then the atmospheric pressure that is in mercury. So cannot mix together. So we need to calculate by separate. So I need to list out oxygen pressure equal H rho G water plus H rho G atmospheric pressure. Okay, so I need your help to show me your answer. How to get the answer from the oxygen pressure. So both density you also need to use. Okay, so please do now. Okay, maybe this one takes some time lah because you do the more calculation. So I just wait you give me the answer. Okay, I go to drink water first. Okay, so anybody here can finish? Okay, you need to do two part. You do the water first. After that, you go to plus the atmospheric pressure. Okay, remember in meter, if cm, you need to convert become meter. Okay, we can see how many here already finished. Can show me the answer. Okay, still waiting. Okay, Sabrina, give me already. 104,590.3 Pascal. Okay, we're going to check first. Okay, first one, I'll show the calculation. 0.38 is the differences. Multiply with the water density, 9.81. So this one is the atmospheric. 0.756 because you divide by 1,000. Multiply density of the mercury, then 9.81. So final answer, yes, 104,590. Okay, you got point 0.3, then you put point 0.3, then Pascal. Okay, this one should be the answer. Okay. Okay, so this one we need to do two part lah. Some of the question like this. So this one question normally you can guess because they give you two density. So normally they give you the info we need to use lah. They give you two density, that means this one calculation must be involve two density. Okay. So from here, this one the answer. Okay, only Sabrina can be answered. The others, I don't know. You can show me the answer or not, or you don't want to show. Depends for yours. Important you know how to do the calculation. Okay, then we go to the next part. Okay, next part is describe. Okay, what happened to the level of the water in the manometer when the stopper oxygen cylinder is removed. Okay, this one is a stopper here. I go to remove. Okay, when I just go to remove, understood the oxygen will out lah, is it? When the oxygen just out, that means what will be go in? Atmospheric pressure will be filled in the tank, is it? So when I just fill the tank, that means atmospheric pressure will come down to the arm, is it? So what happened? So what happened for these two parts? So now atmospheric also here. This part also is a atmospheric. So understood, the atmospheric will push. Okay, the left hand side will push the mercury go down because here become low pressure. Okay, low pressure already because your oxygen leave. Okay, after that they will push until the certain level, both side the mercury sorry, not mercury, water. So now the atmospheric pressure will push the water level until the certain level becomes same. Okay, becomes same, that means now both side also just acting by the atmospheric pressure. So from here, the first step you must say oxygen out. The oxygen will flow up from the cylinder. Okay, so what will go in? Atmospheric will go in. So from here, the oxygen pressure will be decreases until they will equal to the atmospheric pressure. Okay, force the oxygen out, then the atmospheric will come in. So oxygen level become less, less, less. So this one water level that can be pushed by the atmospheric pressure, then this one another arm will be up. So from here they say the water level in the left arm, this side, okay, will be drop. Okay, can drop, then another side sure up lah, is it? So that means the water level in the right arm of the manometer that will rise. Okay, rise until the water level in the both arm become the same. Okay, how many they up we do know. We just know until what level they will stop. When the both level is the same, then they will stop to push. Okay, so we got 4 points you need to answer. First one, talking the oxygen out. After oxygen out, what happened? Inside the tank, the pressure become less because they already covered by the atmospheric pressure. When this part the pressure become less, understood atmospheric pressure will push. So you must mention the left arm. Okay, the water level will drop. Then the right arm, the water level will up. Okay, until when? Until the both side. Okay, both arm, the pressure become the same, then that will stop to push. So from here, you can find the water level become same level. Okay, so this one is how to explain when the stopper just remove. Okay, then we go to number four. Number four is one of the question almost same like the essay. You need to give the explanation. Okay, so now they intend to build the three type of the manometer. They provide three types. One is a mercury, water, and also olive oil manometer. Now you need to discuss the advantages and disadvantages for three type of the manometer. Okay, now we're going to see what's the important for manometer first lah. Why every time we go and choose the mercury? Okay, first one, mercury density is higher. Okay, if mercury density is higher, what advantages? They can measure the highest pressure liquid. Okay, sorry, liquid pula. Okay, they can measure higher pressure of the gas pressure. Okay, we do know what pressure. Maybe you got A pressure, so they can measure the more higher pressure lah if you're using the mercury. Okay, number two, mercury got one thing that's a very good. They're just like the thermometer inside also mercury, is it? They never stick on the glass. Okay, if they stick on the glass, that means you cannot read what? Because they drop, they up, they will stick. Then after that, you do know which one is the readings. But the mercury is no, they never. Okay, they never stick on the glass. After that, they can expand, then come down faster. So compared to the water and oil sure will stick on the wall. So that means you cannot read the readings as perfect. Okay, number three, if you say safety, mercury sure cannot compare with the water and olive oil lah, because mercury we know everybody, and then there's a poison liquid. Okay, so from here we need to discuss about the three advantages and also disadvantages for certain of the liquid, mercury, water, and also olive. Okay, let's see here. Okay, first one you can write in table form. Okay, factor, after that comparison, then the suitability. Okay, first one you're talking density. Okay, you see the first one. Density water is slightly higher than the olive oil. Okay, number two, but density for the mercury is a much, not just higher, it's much higher than the density of the water and also olive oil. So from here, what's the advantages if higher density? The mercury manometer is suitable for measuring the high pressure. So this one is the first, the advantages if you're using mercury manometer. Okay, number two. Okay, adhesions to the glass tube. That means they stick on the glass tube. Mercury is does not stick on the glass tube. Okay, how about the water and olive? Water and also olive oil, they will stick. Or they say wet the glass tube. They will wet the glass tube. That means after that you want to read is very hard. Okay, mercury can be filled into the manometer and also removed without leaving any residue in the glass tube. They never put any extra, the sisa. Okay, the lifting they put there, no, they exactly bring down. Okay, but the water and also olive oil they will leave there. Then say it is difficult to clean the glass tube if you're using the oil. Is it? That's the reason why we don't want to using the oil. First one, low density, easy to evaporate. After that, they also very hard to clean the tube. Okay. So, and the last one is talking about the safety. Okay, safety. Mercury sure is very toxic liquid. Okay, but the same water and also olive oil sure safe to use lah. Okay, if you're still using the mercury, the precaution you have to be closely followed when handling the mercury. So this is one of the disadvantages if using the mercury. So from here, suitability, we need to choose which one we need to use. Okay, the water manometer is suitable. Okay, oil is totally out. Okay, water manometer is suitable and also safe to be used, but only to measure the not much higher pressure, okay, than the atmospheric pressure. That means something is less than atmospheric pressure. That means we can using the water manometer. because water manometer using for the atmospheric already 10.2 meter, you know. If you less than atmospheric pressure, okay lah, we still can using the water. But if you more than atmospheric pressure, so better we will choose mercury manometer. Okay, so normally we measure all the gas pressure, there's a over atmospheric, so we choose is a mercury manometer is more suitable. So the necessary precaution you need to take about that lah. That means you need to do some overtaking about the mercury when you just handling. Okay, must be careful. So this one is a advantages and disadvantages. So from here we can choose water, then you give the reason. Then you choose mercury, you also give the reason. Then you must say what you need to add, precaution you need to add. So this one is the answer for the essay. Okay, something like this lah. This one is a one type of the essay, just comparison. Then talking about advantages and also disadvantages. Okay, I got add two more questions. So student, you can follow here. Okay, do calculation again. Okay, now a mercury manometer with one end arm. Okay, gas supply is shown in the diagram below. Okay, the density of the mercury. Okay, they give you the mercury density. Atmospheric pressure 76 cm mercury. Gravitational acceleration 9.81. What is the gas pressure in unit? Cm mercury and also Pascal. So info first. Okay, info. Atmospheric pressure 76 cm mercury. Gravitational acceleration 9.81. Density of mercury 13,600. Okay, gas pressure. Okay, first you give me the answer in cm mercury. Okay, I want to answer A first. Okay, in cm mercury, what is the gas pressure? Okay, so now you start, you do your work, calculation. So this one got, you need to do one more step. Okay, you see the diagram, you need to do one more step because here they say 12 cm, then this one is a 5 cm. So what is the differences? You need to find out the differences first. Then after that, you can do the calculation for gas pressure in cm mercury. Okay, got anybody here? Okay, get answer already. From the Sabrina again, 7 cm Hg. Okay, we're going to see is it correct or not lah. Gas pressure. Okay, Sabrina, you just give me the difference only. I want gas pressure. Okay, I want a gas pressure. Don't forget got atmospheric. Okay, you just give me the differences. Differences pressure. I want what is the gas pressure? Gas pressure, gas pressure, that means you need to find the differences and also you need to plus the atmospheric. Okay, Yiru, they give me the answer. It's 83 cm mercury. Okay, we go to check. Okay, gas pressure is a H rho G, but this one we're just using cm mercury. So we go and see what is that. Okay, P equal 12 minus 5. Okay, there's a cm, 7 cm mercury. Okay, don't forget atmospheric pressure, you need to plus because they ask about gas pressure. They're not asked about the differences. Okay, so from here after minus 7 plus 76, so the answer is 83 cm mercury. Okay, correct. 83 cm mercury. Okay, now you need to convert this unit become Pascal. Okay, just a simple things only. We do so many time already. Okay, now you give me the answer for the Pascal unit. Okay, just convert become Pascal. So the info still here. Okay, the info still here. So that means you need to show the formula. Gas pressure now is H rho G. Okay, convert in Pascal. Remember the 83 cm you need to convert become meter. Okay, so also wait for your answer. Okay, so from here, Jaya only answer one question. Don't know Jaya go where already. Okay, Eric. Eric also can answer. Ling Han, you also can answer. So I want the answer in Pascal. Okay, what is your answer? Just using the 83 cm, you convert become meter. After that, we can do the calculation by using H rho G. Then you can get the answer. Okay, anybody here? Okay, Jia Yao. So every time the Jia Yao want to kick one time, then Jia Yao come out. Okay, so the answer is a 110735.28 Pascal. Okay, so from here, gas pressure H rho G. So the answer, okay, exactly the same. Okay, correct, Jaya. 11075.28 Pascal. Okay, so this one is how we convert cm mercury and also go to the Pascal. Okay, continue, Jaya. The next question. Okay, we go to the next. Okay, question number 6. Okay, diagram they show about water manometer. Now is water manometer. Okay, to determine the gas pressure, calculate the gas pressure. First one in cm H2O, another one in Pascal. Okay, the info already is here. The info is here. Atmospheric pressure is a 1000 cm H2O. Density for water is 1000. This one is a G. Okay, first one, I want you to give me the answer in cm H2O. Okay, what is the gas pressure? Okay, in the unit cm H2O. Okay, it's the same thing. You need to find the difference first. After find the difference, you need to add atmospheric pressure. Okay, continue. The student Ling Han, Eric, where are you? Okay, Jaya 1020 cmH2O. Okay, we just plus like it. So from here, gas pressure equal water pressure plus atmospheric. Okay, so should be plus only. 25 minus 5, remember, this one is a differences. Okay, we need to find this one difference height only. Okay, after that, we go to plus 1020 cm H2O. Okay, so this one in the unit cm H2O. Okay, now convert to Pascal. Okay, convert to Pascal. So it's the same thing, but this one you need to using density for water. Okay, anybody can reply here. Okay, the formula is a H rho G. Gas pressure equal H rho G. Then remember your cm must convert to meter because your answer in Pascal SI unit. Okay. Okay, Yuan Ru. Okay, Eric, come on already. 1062. Okay. There's 100,062 Pascal. Okay, now we go to show. Okay, exactly correct. Okay, so this one is the answer for the gas pressure. Normally, they want to find a different unit only. Important, you know how to see the level. Okay, so finish. Okay, the application for the question already finished. So the next lesson, I think we will in the school. Okay, I will see you in the school. 2.4 Pascal principle. Okay, what you need to do today, you need to do your module. Remember your module. I don't know how many students want to take. The module you have me to finish until gas pressure. Okay, for my student. Okay, one more thing. Today attendance, you need to key in the Google form. I think I already upload in the Telegram. The Google form inside got 5 questions about the gas pressure. So you need to answer it. Okay, today code. Okay, 加油 help me to type. Today the code is gas, capital letter gas, GAS, underscore, pressure, capital letter PRESSURE. Okay, so all capital letter, no spacings. Gas, you put underscore. Okay, after underscore, you put capital letter again, pressure. Okay, Pressure. Okay, then that one is a 2-day code. Okay, so don't copy paste. Don't copy paste. Straightforward, you go in, you need to type. Yes, correct, Jaya. Gas pressure. Okay, so you need to go to answer lah. Answer the 5 question about the pressure. Okay, so our lesson, I think just until here. So the next lesson should be in the school after 1 week holiday, then go in after go to school. Okay, one more thing. Please go and take back your file. I already put there. Okay, some students still don't want to take. Okay, take back your file before the school is open. Okay, so finish my lesson just until here. Okay, everybody enjoy your 1 week holiday. After that, see me again in the school. Okay, bye, Sabrina. Thank you. Iru, thank you. Okay, go. Okay, Ho Jiayao, thank you. Okay, Yuanru, bye. Thank you for your watching. Okay, bye, everyone.